Microsoft Sheets has an interesting concept. Now, I did have Microsoft Sheets, but I can tell you what the interesting concept on Microsoft Sheets were. Like any platform, their sheet is supposed to go on forever. Here is the problem. While there's infinite numbers to go down, there aren't infinite letters to go horizontal. So when we arrive at the last letter of the alphabet, what is the next? Now, a lot of people that use Microsoft Sheets know what comes after Z. But before I explain that, let's learn something else to combine with that. So there is this language where you can convert numbers into letters and letters into numbers. Since alphabet letters don't go on forever like numbers, we will discuss how to turn alphabet letters into numbers first. Think of it as like this. A is the first letter in the alphabet, the first letter you say in your ABCs song. Therefore, A is equal to 1. B is the second letter, so it's equal to 2. And so you eventually get the Z, which is the 26th letter of the alphabet. But what comes after that? In other words, what would be the 27th letter of the alphabet? Well, since there are 26 letters, we can convert this into 26 spaces, meaning we would go back to the first letter in the base, put it in the tens place, and take the first letter in the base again, and put it in the ones place to get AA. A is the first letter, the other A is the first letter, that makes 11, but that's not the correct way to do that. Since B is the second letter, the 28th would be AB, then the 29th would be AC, and the 30th would be AD. This keeps going until we get to AZ. The first letter of the alphabet in the tens place time is now up, so we have to convert to the next letter and put it into the tens place. After A comes B, so B will be taking over into the tens place, and Z, the last letter, will restart back from A, the first letter. So after AZ comes BA. As you can see, the pattern follows. When we get the ZZ, we've run out of every possible connection we can make for 2 digits of a 26-base letter system. So we switch over to the 3 digits, which are just 3 A's, where last time we saw 2 A's. So it's an upgrade. Now in Microsoft Sheets, you can see that after Z comes AA, the exact thing I'm discussing. But unlike Google Sheets, it would go to BBCC, it would go to AB, AC, AD. Okay, so yeah, what is this called? This language is called the bijective base 26 system. Now let's learn how to convert numbers into alphabet letters and alphabet letters into numbers. Okay, starting with how to convert a number into a letter. So for example, we have 55, so we put 55 here. Then we divide it by 26, but not with annoying decimals. We have to have a remainder. So do long division. 26 can't go into 5. 26 can go into 55 2 times. 26 times 2 is 52, so we're going to put 2 over there. Subtract, we have a remainder of 3. Now we have 2R3. Cancel out the R, and we get 23. Now split the 2 and the 3 into their own digit, and the second letter of the alphabet is B, and the third letter of the alphabet is C. So BC is the answer. Therefore, 55 in the bijective 26 base system is just BC. Now let's teach you how to convert alphabet letters into numbers. Our example is BN, so we put BN down, and just like place value, numbers to the left get smaller, numbers to the right get bigger. So this number to the right is of course the tens place and the ones place, just to let you know. Now we start at the smallest place and go left or to right. So the ones place is N, and we're going to put 26 on the bottom since there's 26 spaces. And we'll start by putting the power of 0. Then we move on to the Next digit, which is b, we put 26 and upgrade the exponent by 1. So now it's 26 to the power of 1. Now n is the 14th letter of the alphabet. B is the second letter of the alphabet. So we're going to go with 14 and 26 to the power of 0 and times them. First, simplify the exponent. 26 to the power of 0, or any number to the power of 0, is obviously 1, so now it becomes 14 times 1, which is 14. So to save time, you know that any ones place in the alphabet letter is automatically itself. So instead of doing that math, so we could just put n as 14 plus something else, since n is the 14th letter of the alphabet already. Now we have 2 times 26 to the power of 1. Simplify the exponent, and any number to the power of 1 is just itself, so we can cancel out the 1, and now we get 2 times 26. 2 times 26 is 52. Now we have 52 and 14. We have to add them, or find the sums of them. 2 plus 4 is 6. 5 plus 1 is 6. So the answer is 66. That means Bn in the bijective 26 system is converted into 66. Woohoo! You just learned what the bijective base 26 system was and how to convert letters and numbers into it. Don't forget, you can deal with bigger numbers, since the bijective base 26 system goes on infinite. 0 does not exist in the system and is instead just replaced by itself, just 0 itself. So you do not need any letter to represent 0, which makes it special in the system. Now let me tell you why it's useful. When dealing with bigger numbers, since letters have more digits in their base, you can make a number shorter by converting it to an alphabet letter combination. So this 4-digit can become 3-digit letters. And here is why this system is useful when converting alphabet letters to numbers. So when converting alphabet letters, you can make words with them, and this is something that might be pretty fun to play around. You can even have your name, which for example is Luke, and convert it into a number, which is for anyone named Luke, your number in the base 26 bijective system is 225,399. How cool is that? Of course, this video is not meant to be taken seriously. Before I go, I'll show you a time lapse so you can get a bigger idea. Thank you for watching. Hope you learned the bijective base 26 system, and don't forget to like and subscribe. See you guys in the next video.